Hey there. Today we are going to talk about intralogistics and automated guided vehicles as well as automated mobile robots. And there are two things that I want you to learn today. That's two objectives. We're going to talk about trends in intralogistics and smart manufacturing, as well as potential and challenges of AMRs compared to AGVs. Well, the agenda is we start with intralogistics systems. We talk about, well, the definition of intralogistics, as well as the trends. And then we compare AGVs and AMRs. And then I will give you a case out of my experience in the automotive industry. Well, how to establish AMRs in smart manufacturing. And we finish with a short wrap-up. Well, let's repeat the definition of logistic systems. Well, the necessity for logistic arises because there's a gap between time of production, time and space of production, and time and space of consumption. So you somehow need to execute logistical tasks. And normally they are organized in networks, and logistic networks consist out of nodes like warehouses or cross-docking points and edges. That would be the transportation line or lanes. And well, you always have something with information and communication systems. And very important is always to remember that logistics always tries to keep up a holistic view onto a whole system. And if we have a look at intralogistics, which is quite a new term, it was invented in 2003 during a conference at a German fair. It's quite similar. So there are four main tasks of intralogistics, which is the organization, the control, implementation, and optimization of internal material flow. Well, and the flow could also be information or goods. So it's always belongs to internal processes, whether it's in the industrial trading companies or public institutions. This one is the very first definition of intralogistics, but you will find a lot of more now in the internet. But as you can see, they all sum up somehow that you are actually optimizing, integrating, managing the internal material and information flow. So it's quite similar. Here's some definitions. And well, if you ask yourself, what does the intralogistic branch, what are the main players in the intralogistic sector? Most of them somehow are concerned with warehouse systems, material flow, whether it's on the floor or up in the air, so cranes, material lifting, packing technologies, logistic software. And there's also, well, you can see that especially in Germany, almost 80% somehow work in one of those sectors on the left-hand side. So let's have a look at trends in intralogistics. And well, somehow there seems to be a great need for innovation and technology. And there are two things which are very important at the moment. This is green logistics and Internet of Services or Internet of Things. So somehow you can sum up that the branch is very like, or the intralogistic branch is quite concerned about Intralogistic 4.0, which is kind of a word, a buzzword, like very similar to production or industry 4.0. But what does that mean in this context? So this is a roadmap concerning the logistics or in industry 4.0. And on the left-hand side, you can see like some sectors of the logistics, and line feeding or intralogistics is one part. But you can see where do we come from and where are we heading. So in in logistics, we come from a system which is a lot with manual handling, no automation, decentralized fleets. And today we are probably somewhere in between the third and the fourth column, that we have globalized networks, autonomous driving for some intralogistic fleets. But where are we heading? And this is where the last column, what we can see in the last column. So somehow we are going to be more flexible with predictive maintenance, predictive delivery management, autonomous fleets, and no warehouses. And if you want to sum up, what does Logistics 4.0 mean is that systems become more autonomous and they will be more intelligent by themselves. So the system in itself becomes more efficient, effective, connected, and agile. And you try to meet the needs of real-time demands. So let's have a closer look at Intralogistics 4.0. That would be this column. Where do we come from and where are we heading? So here the word FTS is synonym for AGV, so automated guided vehicle. So we come from from the 90s where they were established or introduced. They're quite established right now, AGVs. We come from a system with fixed routes, and now we are somehow having AGVs with open areas and more possibilities to steer. And we're heading to a future with autonomous mobile robots, which can steer themselves or by themselves. So let's have a closer look. What does that mean, especially for AGVs and AMRs? So let's compare those two types. Well, both of them are used to transport material. And normally the aim is to maximize the throughput. So let's have a look at how do they look like. Well, it's quite difficult to, from the outer appearance to say whether it's an AGV or AMR. But as you can see here, automated guided vehicles are normally following something like maybe something on the floor, marked lines, there are wires, or they have radio waves. So you see somehow how the navigation works. Well, when I did an internship at a major automobile production site, it was quite interesting because it was always the task for the interns. If there was a change of process and you had to change the way the AGVs should move, there was one task to untape those guided lines on the floor and to tape a new one. So there's always something with you will see the navigation. And AMRs, they might look like almost the same because they are still portable robots, but they have sensors and onboard computers, so they can kind of dynamically route themselves through the plant or map themselves through the plant. And well, imagine yourself, you're an intralogistics manager, and you should kind of renew the fleet to move the material inside your warehouse. Well, and then you'll look it up and you are like, okay, there are AGVs, there are AMRs. What are the decisive factors for the selection of either one of them? So you think about navigation, deployment, operational flexibility, the responsiveness, and well, of course, the costs, quite probably one of the most important factors, and then also setup. So let's have a look. Well, you will see like the AGVs, we have already talked about that. They are always somehow stripes, wires installed on the warehouse floor or somewhere else. And AMRs are guided by sensors and steering logic, which is inside of the robot. Well, AGVs require installation and navigation guides. And AMRs require little installations for themselves, but you need a software platform. We will talk about that later. Well, if you want to change the way the AGV is moving, we have already talked about it, you need to repeat the deployment process. So you need new magnetic stripes, or you need to, if you need a new AGV, it's always, you repeat the deployment process. And the AMR, if you change the process, it dynamically plans the shortest path. So there is less work while setting up those robots. So if there is, for example, something on the floor, like someone, maybe you left something on the floor, a big package with material, and it's somewhere on the marked line for the AGV stops. It makes some noise, maybe, but well, it wouldn't move until you remove the stuff which is on the floor. And the AMR, for the AMR, it's just possible because it recognizes that there's something on the route, that the best route is blocked, so it will automatically move around. Well, let's talk about the costs. AGVs, well, if you buy an AGV, it's less costly per robot, but you have higher costs to set it up and deploy it, especially if you have to provide the infrastructure. And the AMR, it's more costly per robot, but yeah, you have the cost for the software platform, but the deployment costs are less. Well, both systems kind of need experts to set it up, but some AMR providers will try to, well, explain that it's quite easy to set them up. You just unbox them and they will work. But you still have to implement the software platform for the steering logic. So let's have a look at integrating AMRs in smart manufacturing. Well, especially in the automobile industry, the new technical possibilities are used especially for warehouses and for order part picking in the logistic process. But you will hardly find AMRs at the final assembly where the automobiles are produced. So the big question is, how can an alternative system look like in order to meet, well, the new requirements for customized products and also the requirements for logistics 4.0? If you think about it, we had those 4 points: efficiency, effectiveness, connectivity, and flexibility. And well, you will find in the throughout the OEMs that they are still having those lines which are quite well, not dynamical, but as you can see, they are one-dimensional assembly line. And here you can see an example how it could look like if you have a flexible assembly line with AMRs and, well, and a software platform with artificial intelligence. So the car still moves from one section to another, but the AMR itself decides which section or part is going to be the next one, or which assembly station is going to be the next one. And this is going to be the next big step in the automotive industry in order to become more flexible. But the big question is, well, why don't they use it right now? Because the technology is already there. You'll find AMRs on the market. But the big thing is that you need new planning methodologies, and you also need to adapt the shop floor management. And it's a shift in paradigm. So it's quite a hard and still a big step for the automotive industry to establish AMRs at the final assembly. And that's just one thing I want to show you how difficult it can be, even though the technology is already there. So just to shortly wrap it up what we have heard today. Well, smart manufacturing for intralogistic means that you want to add the right level of autonomy, intelligence to your systems in order to become more effective, efficient, connected, and agile. Remember those 4 points of smart manufacturing. And you always want to meet real-time demands. But we also saw some, well, there are a lot of potentials of AMRs, because they dynamically plan, they drive autonomously. If there's something blocked on the route, they find the new route or reroute itself without assistance. And they might also, well, if you use them at assembly lines, they might optimize the whole assembly line, and well, that means that the flexibility rises quite a lot. But on the other hand, you need new planning methodologies, and you need to adapt the shop floor management. And as we have heard at the very beginning, you always need a holistic viewpoint at logistics. So you need a holistic integration of those AMRs into the whole logistics system.